This is Writing and Graphing Inequalities Part 2. The graph of an inequality is placed on a number line. On that number line, we are showing all the possible solutions for that inequality. When we're doing this, we use an open circle when we have a greater than or a less than sign, because the number we're comparing our variable to is actually not a part of the solution. It cannot be equal to that number. When we have a less than or equal to or a greater than or equal to sign, we used a closed circle, because in that case, the number we're comparing our variable to actually could be a potential solution. So let's see how this works. Here we have x is less than or equal to 6. 6 actually could be the answer here because we see this equal sign here. So when I go to 6 on my number line, I'm going to use a closed circle because I'm saying 6 is part of the solution. And basically anything that is shaded is a potential solution. So I'm closing in the 6 there. I also know that x is anything that's less than 6. Equal to or less than 6. So all the things less than 6 are this direction, going to the left. So what I would do is on my number line, I'm going to shade everything to the left here. Okay, so I'm making the line much thicker. And I'm even going to make my arrow a little bigger going this direction. So I'm saying everything shaded, everything this direction, including 6, is a potential solution to this inequality. So let's look at a couple more examples here. So in this first example, we have g is greater than -2. So we're comparing our variable g to -2. Since there is no equal sign there, it just says g is greater than -2, I'm going to use an open circle at -2. I'm not going to close it in because -2 itself cannot be our value for g. It cannot be equal. There's no equal sign there. So g is anything larger than -2, which means I'm going to shade this direction because everything bigger than -2 is to the right. In fact, I'll even make my arrow bigger because my number line could keep going and going and going. Any number this direction could be a potential solution. Let's look at this example. F is less than or equal to 7. So this time I see the equal to, it can equal 7. So at 7, I'm going to do a closed circle. I'm going to shade it in. Anything shaded is a solution. In this case, f is less than or equal to 7. So everything less than 7 is this direction to the left. So I'm going to shade everything going this direction, including my arrow, which I will even shade and make larger than the arrow on the other side. Now we can also do the opposite. We can be given a graph and asked to write an inequality. So in this case, I'm going to have a variable. It doesn't matter which variable I pick. Let's say I pick p. And I'm comparing p to -3. I know that because my dot is at -3. Now I have to decide what sign is going in between those two. I know that the sign that I pick has to have that equal sign as part of it because I have a closed circle here for my circle at -3. I also see that everything is shaded over here to the right, which means my answers are bigger than -3. So p has to be bigger than -3. So there is my inequality. Let's try another one here. Once again, it doesn't matter what variable I pick. Let's say I pick r. I'm comparing r to 0. I know that because my circle is at 0. But this time the circle is open, which means I'm not going to include an equal sign. I'm going to use a greater than or a less than sign here, but no equals. So in this case, I see the numbers that are shaded are going to the left. They're things that are smaller than 0. So r has to be less than 0. Now let's take a look at a real-life application, a word problem. This word problem says that the NASA Solar Probe Plus can withstand temperatures up to and including 2,600 degrees Fahrenheit. They want us to write and graph an inequality that represents the temperatures the probe can withstand. So let's start by writing an inequality. So we can pick any variable. I'm going to pick T for temperature. And I know that I'm comparing the temperature to 2,600 degrees Fahrenheit. So it says, if I read again, that the probe can withstand temperatures up to and including 2,600. Since it says including, I'm going to include an equal sign. It can actually be equal to that. The temperatures have to be smaller than 2,600 because it says it can withstand up to this temperature. After that, it's going to start disintegrating. So the temperature has to be less than or equal to 2,600. So I'm going to put 2,600 on my graph here. And a couple of numbers larger and a couple of numbers smaller. And in this case, I'm going to be using a closed circle at 2,600 because I have the equal sign in my inequality. Now, we said the temperatures have to be smaller than 2,600, so everything smaller on a number line is always to the left. So I'm going to shade everything to the left, including my arrow, which will even look a little larger than the arrow on the other side. And now I have graphed all the solutions. Anything going this way, including 2,600, is a temperature the probe can withstand.